All right, a few more conceptual questions. Go ahead and read through this. All right. So in case it's not obvious, all 5 of these pictures represent a view from above. So we're looking down at the turntable. The little circle, little tiny dot is our coin. And we're asked to find which forces act in the plane of the turntable. So the coin is sitting on the turntable, therefore there must be some sort of force pointing towards the center. So E cannot be correct. To narrow it down from there, we do need to know what it means if the turntable is steadily rotating counterclockwise. That means it's not speeding up or slowing down. Steady speed, rotation speed, means there cannot be any force that is tangent to the circular path. There has to be a force towards the center, and it is specifically going to be the force of static friction that points towards the center that's not allowing the coin to slide off. So again, the term centripetal force is not some new force. It's whatever force we're already familiar with that is causing the motion. Let's look at another one. What do you think here? The correct answer here is B. So building on the last problem, it's the force of static friction on either one of them that is causing the coins to move in a circle. And so that static friction force is going to equal the mass times the centripetal acceleration. We can substitute in either the r times omega squared or v squared over r. Let's do the r times omega squared. The reason I'm choosing omega, so again, omega, remember, is the angular speed. It's the radians per second the turntable is moving through during this problem at any given moment. The reason I'm going to write omega is because I know omega is the same for coin 1 and coin 2. Now, in terms of the coins flying off or sliding off, essentially, I can plug in our maximum friction force. The turntable is horizontal, so the normal force up on the coin will balance out with the force of gravity downwards. So I can set this up. This omega represents the maximum angular speed or rotation rate, you can think of it that way, before the coins slide off. Because this is the biggest the force of static friction can be. Well, we see r in the denominator down here. The smaller the r value, the bigger omega can be before that coin slides off. So coin 2 has a larger r value, which means a lower angular speed at which it will slide off at. So coin 2 will slide off first. Let's look at one more question for this video. What do you think? The correct answer is D. So if we imagine we could somehow see this child on the seat as this bus is going to make the right turn. And we're saying this child is not sliding on their seat. That means there has to be some sort of force that causes the child to turn with the bus. So the force needs to be in a direction that points towards the center of the circle, the center of the curve that the bus is moving in. And so that's why there must be a force parallel to the seat directed to the right. So again, the right side of this bus is on the side, and so that's why directed to the right. Now it's common to want to say left, because if we've ever been in the car and we make a right turn, especially if we make the turn quickly, we feel like we're getting pushed to the left side. But we're not. There's no actual force causing that. That's the law of inertia at play. Our body wants to continue moving in a straight line, but the car, the seatbelt, the seats, the door of the car, it's not allowing us to keep moving in a straight line. And so we get pushed into the side of the car. So in this section, we don't want to really look at what we would feel per se in determining the answers here. We have to be an outside observer to accurately account for things.